Hello, it's Malcolm again. Okay, so you've had a go at the creases problem, and I don't really mind at this stage how far you got through it, because what I want to talk to you about now is what you actually did at the beginning of trying to solve the problem. And I would suggest that for most of you, the first thing you actually did was got yourself a physical piece of paper. So, you got your piece of paper, and you folded it over. So, physically folded it. So there you go, you made one fold, and when you open it out you saw one crease. Then fold it again. Now I guess some of you may not have folded it this way, you might have folded it that way, in which case you're looking at a different problem to me, but that's okay, you can solve whichever problem you feel like. It's the problem that you want to solve that you actually work with, but let's for the moment pretend that we are going to keep folding in the same direction. So I fold over again, so now I've made two folds, and when I open that out I have 1, 2, 3 creases. And I guess at this stage you probably tried to be a little bit systematic and record your results. So if I had one fold, then the number of creases was 1, but when I had 2 folds the number of creases was 3. What happens when I have 3 folds? So here I go, I've folded it once, folded it twice, let's fold it a third time, open it out. I have 1, 2, 3, 4, 5, 6. I have 7 creases, and so on, and you would keep going. In this problem, it seemed pretty natural that picking up a piece of paper and folding it would actually help you work with the problem. But this is an example of what mathematicians do all the time when they don't know what to do with the problem. They'll try to find something that helps them do the work. They will try to find something that's easy to work with. And we call this process specialization. An informal definition of specializing might be: specializing is the process of using something that can be worked with in more confidence than the problem as given to you. So, in the creases problem, you could work with the piece of paper with more confidence than if you had to work with it just in your head. And so picking up that piece of paper is an example of specializing. Of course, as you have more experience in solving problems and see more examples of specializing, your understanding of this term specializing in terms of solving mathematical problems, you'll come to a more fuller understanding of that particular term. But anyway, let's move on. Why is specializing good? Well, the purpose of specializing is to get you started. So if you're facing a problem and you've got no idea what to do, well, something you can do is specialize. In this case, in the creases problem, pick up your piece of paper. It gives you something to do. Once you're playing with the specializing, it might give you an idea of what's happening. For example, here we found that as we had more folds, there were more creases. So there's an idea of what's happening. It makes it possible, perhaps, to detect patterns. So, for example, we saw 1 fold, 1 crease, 2 folds, 3 creases. Maybe there's a pattern there. If we hadn't have specialized, we wouldn't even have noticed this or wouldn't even looked for that. So by specializing, we've got started, we've got an idea of what might be happening, we're even getting where we might be able to detect a pattern. And so overall, specializing generates confidence and helps us keep going in our task of solving the problem. Okay, so far you've solved just one problem and seen one example of specialization. It's time now to move on to another problem. See you then.